Okay, so this is Math 090, Week 4, Part 2 lecture. We're going to discuss the properties of real numbers and simplifying expressions. So, a couple properties of real numbers. Multiplication is both commutative and associative. Commutative means the direction doesn't matter. If you multiply 2 times 3, you're going to get 6 if you multiply 3 times 2. So multiplying backwards and forwards doesn't matter. Associative property means we can associate numbers that are being multiplied in different groups. So notice here we have a -1, a 3, a 2, and a -2. 4 different numbers that are all being multiplied. So remember, we have to multiply 2 at a time. It doesn't matter which 2 we group together, and it doesn't matter which direction. So down here I've grouped them a few different ways. I've left the -1 out, and then I grouped the 2 and 3, which gives us 6. Then I grouped the -1 and 6, which gives us -6. Then the -6 times -2 gives us +12. Here I rearranged them. I took the -1 and the -2 and put them in the back and then grouped them together. So 3 times 2 is 6, -2 times -1 is +2, 6 times 2 again is 12. Here I grouped the 2's and then the -1 and the 3. 2 times -2 is -4, -1 times 3 is -3, -4 times -3 again is +12. So no matter which 2 you multiply first, you're going to get the same +12. When we are multiplying fractions, you multiply the numerators and then you multiply the denominators. And again, don't forget, you always reduce. After you're done doing your operations, you want to go ahead and reduce any outcome. If your final answer is a fraction, you want to make sure it's in lowest terms. The sign rules for multiplying fractions still apply. If you're multiplying 2 negatives, it's positive. If you're multiplying 2 of the same sign, it's always positive. 2 positives multiplying give you a positive. 2 negatives multiplying gives you a positive. Different signs, if you're multiplying a negative and positive, you always end up negative. Now, when you're multiplying fractions and one of the numbers happens to be a whole number, we can always turn a whole number into a fraction by placing it over 1. So this 3 is the same as 3 over 1. So we have -5/8 times 3 over 1. We multiply the numerators. So the negative is either with the numerator or the denominator, not both, right? Because a negative over a negative is positive. So I always tend to just associate the negative sign with the numerator. So -5 times +3 is a -15. 8 times 1 is 8. When we are dividing fractions, remember, you always convert it to a multiplication problem, but you cannot simply change division to multiplication. You have to also take the reciprocal of the fraction that's doing the dividing. Reciprocal again meaning the flip. You invert the numerator and denominator. So -9/10 divided by -3/2. First of all, they're both negative, so your answer is going to be positive. We change this into multiplying, keep the -9/10, and we flip the -3/2 to become -2 over 3. So once we change it to a multiplication problem, we know how to multiply. You multiply across the top, then you multiply across the bottom. So -9 times -2 is a +18. 10 times 3 is 30. Final answer, always make sure it's in lowest terms. We can divide top and bottom by 6. They have a common factor of 6. So we end up with a +3/5. Okay, so exponents represent the number of times a base is being used in multiplication. Okay, some people like to say an exponent is the number of times something is being multiplied, but that tends to make you assume you have that operation that number of times. For instance, if I take 4 to the second power, I'm not multiplying 2 times. I'm only multiplying once. It's just I'm using the 4 twice in my multiplication. So there's not 2 operations of multiplication. You're using the base twice in a multiplication problem. So 4 to the 5th power, I'm going to have multiply 5 4s. So notice there's only 1, 2, 3, 4 multiplication symbols, but we have 5 of the 4s. Now you have to be careful when you have an exponent with a signed number, because -4 squared and -4 squared have 2 different meanings. Remember, -4 means the opposite of 4. So this is saying I want to take the opposite of whatever 4 squared is. So I want the opposite of 4 times 4, which gives me -16. Here, though, it says I want to square the opposite of 4. So I want to use the opposite of 4 twice in multiplication, which gives me a +16. So you have to be careful where that negative sign is. If it's just out front, the exponent does not apply to it. But if it's inside parentheses, the exponent does apply to it. So looking at this problem here, we have -3 to the 3rd and -4 squared, which we actually already did, the -4 squared. But -3 to the 3rd power, this says I want 3 of these, 1, 2, 3, in multiplication. -3 times -3 gives me a +9, times a -3 gives me a -27. Okay, so again, or also with fractions, you have to be careful where the exponent is, because with fractions you have a numerator and a denominator. If your exponent, say we have 2/3. If I have an exponent just sitting out here, that exponent only applies to the 2. This is actually 2 squared over 3, which would be 4 over 3. Now, if the exponent is down here, this is 2 over 3 squared, which would be 2 over 9. So the exponent applies only to one, either the numerator or the denominator, unless it's in parentheses. If I have 2/3 squared, this means I need 2 of the fractions, 2/3, in a multiplication problem. So here, this is like saying 2 squared over 3 squared. It's 2/3 times 2/3, which gives me 4/9. And again, think about a negative sign. If we have negative of 2/3 squared, well, I know the 2/3 squared is going to be 4/9, but I want the negative of that, so it's the opposite of 4/9. Now, if that negative is inside the parentheses, this means I want 2 of the fraction -2/3, which would give me +4/9. Okay, so order of operations. Please excuse my dear Aunt Sally. I wrote it like this to point out to you that multiplication and division do not necessarily come multiplication then division. You kind of group multiplication and division together and do them left to right. Same thing with addition and subtraction. Those are done left to right. So instead of writing it like this, sometimes I like to write it like this. So we know parentheses is first. And remember, parentheses includes any grouping symbol. Parentheses, squiggly brackets, square brackets. Remember, even a fraction bar, it'll group the top and bottom separately. Exponents. Exponents also include your radicals, okay? So if you have, like, these come second. If you have 2 squared, that is something that would come second, or a radical 4. You consider the exponents and the radicals at the same level. Then multiplication and division are your third level. Addition and subtraction are your fourth. So multiplication will always come before addition and subtraction, but won't necessarily come before division, because if you have a set of terms and there's a division up here and a multiplication back here, you would do the division first. Okay, and where addition and subtraction come in, if you have a subtraction up here and addition down here, you would do this subtraction first, but if you think about it, subtraction is actually addition of the opposite, so there really is no such thing as subtraction. But you would always do these left to right, so this addition of the opposite would be done before the addition over here, because it's to the left. Okay, so following our order of operations. Our operations here are addition and division. We know division comes before addition, so we're going to do this division first. We have -9 divided by 3, which gives us a -3. So we bring down the -12 and the plus. So -12 plus -3 gives us -15. Okay, so looking at this fraction, again, don't look at it as one entire thing. Look at the little operations. So the fraction bar separates the top and bottom. You decide where you want to work first. It doesn't matter. If you want to work top first, that's fine. Bottom first, that's fine. So let's say we worked on top first. Okay, on top, what are our operations? We have a subtraction, we have an exponent, and we have an addition. The exponent comes first. So this -3 to the second power is going to give us a +9. So we would have 3 minus 9 plus 1, shown right here. 3, and instead of minus, I wrote plus -9 plus 1. From here, we have 2 additions. We do them left to right. 3 plus -9 gives me a -6. So then I have -6 plus 1, which gives me -5. So the top is done. The top simplifies to the number -5. Now we work on the bottom. We have 2 exponents, so we're going to do those first. 2 squared is 4, 3 squared is 9. So we have 4 minus 9. 4 minus 9 is the same as plus -9. 4 plus -9 again is -5. So we have -5 on top, -5 on the bottom. This reduces to a +1. Okay, so here again, we want to follow our order of operations. What are our operations? Well, we have